to our next speaker, who is Ryan Foley from UC Santa Cruz, and he's going to be telling us about the Keck infrared transient survey.
Hopefully everybody can see me. Okay, look good to everybody? I'll proceed. So yeah, I'll talk about the Keck Infrared Transient Survey. Thank you all for attending, and thanks to the organizers. This conference has been really exceptional, one of the best virtual conferences that I've attended. So thank you for giving me the opportunity to talk about this survey, especially since we haven't even started yet. We're starting this weekend. And so this is really more of an advertisement more than anything. So the Keck Infrared Transient Survey, or KITS, as we've been calling it, that name, of course, a KIT is a baby fox. And so I think I'm allowed, maybe even obligated, to show a picture of some kits. This is a good way to start any of our email threads also. This has got a lot of collaborators. This is probably not even everybody. I just grabbed this from Slack, so I apologize if I missed anybody. It's a big group, and so sort of what we ended up doing was we had a combination of the two Roman supernova SIT teams. I'm PI of one, Saul Perlmutter is PI of the other. And then we added in a bunch of additional people who work on non-1A transient observations. And so it's a large group who's invested in this, this program, but we would like to be even larger. So one of the big things I'll point out is that if people want to get involved, please let me know, and happy to add you to the group. There's lots of ways to contribute. Before I get going, I wanted to, despite the fact that this is a lot of people, highlight a few here. In particular, Justin Pyrell provided some plots for this talk. Gao Tenianat, I said just recently we should make him deputy PI because he's been doing so much for this work. Phil, Kyle, and Dave have also been just exceptionally supportive of this program. So I wanted to highlight them, but everybody has really been contributing. And before I go too far, I wanted to just acknowledge the land that I'm sitting in. The land on which we gather is the unceded territory of the Awaswa speaking Upi tribe, the Ama Mutsun tribal band comprised of the descendants of indigenous people taken to missions Santa Cruz and San Juan Bautista during Spanish colonization of the Central Coast, is today working hard to restore traditional stewardship practices of these lands and heal from historical drama. So I'll move quickly through this because I think we've heard so much of the motivation here, but I just love showing this plot. This is on a linear scale, the number of supernovae discovered up through last year, or I guess 2020, so not even last year now. And you can see this explosion. It's so dramatic that really you need to show it on a log scale to get any sense of it. And so one of the things that's fantastic about this is as we discover more objects, we probe the extremes of the explosive territory. We're able to really understand a lot of physics. So kind of generically, exploding stars touch on all sorts of different parts of astrophysics. And the SIT team that I lead, we are really focused on the cosmology aspect of this. But I think there's a lot more that can be done through Roman observations. And so this is a version of a very common plot by Brad Senko, showing sort of the landscape in this parameter space of absolute magnitude and time scale for different stellar explosions and other transients. We've talked a lot about these different classes. And again, just the Roman time domain survey is not going to only be doing the type 1As, it's going to be doing a lot of these other things if we plan appropriately. And I want to point out that even this plot here it needs a little bit of an update. So on the left, I'm showing a recent review article plot on just thermonuclear supernovae and how diverse they are and how many different classes there are within thermonuclear supernovae. On the right, I'm showing a recent plot by Anna Ho using ZTF data and some other literature sources, really showing how new sources, things that have just been discovered in the last few years are filling out this part of parameter space. And new observations now can inform what's going to happen with Roman in a little bit. And this plot has been shown before. This is the expectations of a nominal survey for this high latitude time domain survey for what you can do with type 1a supernovae, where you might find more than 10,000. And so similarly, you would find thousands of other kinds of supernovae, various core collapse things that are relatively common. And then there will be a number of very, very rare things as well. And importantly, anything at redshift below 1, Roman has the ability to observe in the rest frame near infrared. However, the rest frame near infrared has not been really well observed for transients recently. This is a plot from Justin showing the current model that we have for a type 1a supernova in black and comparing that to the filters that we have for Roman. And now this is at redshift 0, but you can imagine that the lack of data out in the infrared is going to make it so that those very red filters are not necessarily used very well. And it's really just an indication that we're lacking data at those wavelengths. Now, as has been noted before, as you add redder bands, and this includes even the redder bands in the optical, you improve distances for type 1a supernovae. And Justin showed that just by extending the data set for this model can dramatically improve the precision that we get at these low redshifts because you're adding more information. Now, in a number of different talks, we've heard about the variety of different transients, and in particular, Eric Schau gave a very nice overview of things on Tuesday. On the left side, I'm showing just his slide that's showing the dramatic differences that different classes have in the infrared. And you can see different lines that tell you all about the composition of these objects and how, the kinematics, those sorts of things. On the right is a time series of this kilonova that was discovered a few years ago by the Ingrave collaboration, showing that there's a lot of information in the infrared for these particular sources that are very exciting. And we can understand some compositional things as we get infrared data. Now, importantly, when we are talking about Roman data, at some point we have to actually plan a survey. So Justin a while ago extended these SEDs into the infrared, but what he found was beyond the type 1As, there just wasn't enough data to do this very accurately with spectroscopy. So instead, he just used photometry. So this is the model for a type 1b supernova that he used that we include in our simulations. He was able to use only 9 type 1b supernovae, 7 type 1Cs, 1, 2b, and 10 type 2s. And ultimately, this can cause some real problems for the predictions that we're trying to make. So here's the comparison, that same spectrum that I showed before in black, now on a log scale, compared to a single spectrum for A1b supernova, this red curve in the infrared. And you can see that there are significant differences where the spectral lines are really strong in the regions where these filters could land. And when you propagate this into what you would expect the differences of the brightnesses or colors of these objects would be for Roman on the left here, you can see that you're getting tenths of magnitude differences in colors depending on which SED you choose. So this can bias your selection of photometric samples. It can bias your selection for spectroscopic follow-up. It can bias all sorts of implications of rates and things like that. It's something that we need to really nail down. On the right-hand side, I'm showing what could be done with JWST at even higher redshift. So if you're interested in, say, pair instability supernovae from population 3 stars, that's really what we need to focus on as well. Now, currently, there are less than 100 public high-quality infrared spectra, and we need hundreds. There have been a few projects that are chipping away at this. We heard a little bit about both Syrah and the CSP data, but they both kind of have some drawbacks. So Syrah, of course, is only for type 1a supernovae. The phase range is a little bit limited, and the wavelength does not go all the way out into the K band. The CSP data is fantastic, but it's not currently public. And just because it was obtained a while ago now, there are some classes that have only recently been discovered, and so they lack data on those classes. So we proposed for and were awarded time through this NASA Keck Key Strategic Mission Support Program. We were awarded 18 nights over 3 semesters, which we've been scheduled a half night every 2 weeks for 1.5 years. In addition, we have a couple of TOs each semester. We're using this instrument NIRAS that I'll talk about in a second, but it essentially goes over the full infrared wavelength, and also has a really nice K-band guide camera that you can get some photometry in real time. There's a bunch of complementary data from lots of telescopes. We would always appreciate it if people wanted to contribute more. And then, interestingly, this will also cover the start of the next LIGO Virgo run. And we hope through this program, through these 18 nights, to have a final sample of about 300 spectra of transients in the infrared. Our first night is this weekend. So, if you want to get involved, there's plenty of time. We're going to be doing this for a while, but feel free to reach out now if you want to get an observation immediately. We have a number of goals here, and I see that I'm running out of time. I only have a couple more slides, but I want to say we want to build this large sample 1A spectra for the cosmology and make sure that we can plan things appropriately. For the other non-1A things, we also need that to help with Roman planning to figure out what really the observations are going to produce. And then there's a lot of explosion physics that we can also look at. This is useful for population 3 supernovae, as I mentioned before. And then, just looking in the infrared at all these transient classes, there are so many transient classes that don't have any infrared spectra. And so just getting data will be really illuminating. And then, we're going to produce this large homogeneous sample for the community so that you all can use it in different ways. I wanted to just show NIRAS on the left-hand side. It's similar to triple spec if you're used to those spectrographs. And on the right-hand side, I wanted to just show some of the data that has been taken with NIRAS. And so in a few days, hopefully we'll have comparable data to show from this program. It should be exciting. And so with that, I'll just say very quickly, we are excited about having new collaborators. So if you're interested, please send me an email. I'll stop there. Thanks.
Thanks, Ryan. Did you show the cute mascot of your program?
I will show. Yeah. Where?
It's okay. For kids. Any questions? Okay. Here we go. Monica, sorry, Sam. Where will the targets be selected from? Any plan to make the kit spectra public near real time?
Yeah, so the targets are going to be selected both through, we're planning on having a pretty systematic survey that's going to be volume limited and magnitude limited. But we want to make sure that we sample the full parameter space. So if there are very exciting rare objects, we're going to target those as well. There's some discussion still about the exact details of this. Of course, when it comes to what we can observe, it has to be visible from Keck. And since we have half nights, this semester we've been allocated only second half nights. So there's a little bit of a restriction in both declination and right ascension. But otherwise, we're open to suggestions for sure. In terms of the data, we're hoping to release the classifications very promptly if we have any of those. And then the rest of the data we're hoping to get out pretty quickly. We said in our proposal we would have a public data release at least after the first year of data, and then a second public data release after the completion of the program. But if we're able to, I think we'll do it even quicker than that.
Okay, so we're running a little bit behind. So Kishale, reach out to Ryan with your question. Okay, thank you so much.